All right.
Okay, Professor, on behalf of management and faculty members, I welcome you for this wonderful webinar today. And
Thank you very much.
I hope this topic is very useful for all the
Student.
participants.
Okay.
So I welcome all the participants for this webinar, and I hope you enjoy this lecture. And I request your professor to start the webinar, please, sir.
Okay, thank you very much. First and foremost, I would like to thank your university for inviting me, and to you, Prof, for this invitation again for the second time. The last time I was there in Chennai. It was a very nice experience.
Thank you.
With all the food and the sightseeing and so on. And to Prof Siva, who was our guide for that. I think 3 or 4 days I think over there. And I want to welcome all the students. These are all the undergraduate, I hope, who are in their first or third year. They're in their third year, is it? Okay, so this talk is about clean combustion, because it's a very, very important topic nowadays due to all these environmental problems that we are having. So luckily with this COVID that happening around the world, so now the environment is getting better due to the lockdown, that so many people are staying at home, no cars on the road or less cars, and then there is what you call it, flight and everything. So that means the environment are getting better now. But after this, we will go back to the usual, and then we have to start to think again about our how we actually live our life, because this is part of what is happening before the COVID-19. So the topic is about clean combustion for future greener environment. Myself is Muhammad Nazri. I'm a lecturer in the University of Technology Malaysia. I've been to Chennai before, to your university. Okay, today is about the environment. So what happened is that, if you know about this story about Titanic that happens in 1912, it's a big ship that was built to take passengers from England, actually in Southampton, to New York to have a new life. So when there was sailing that night in April, actually in April, in the late at night, so the ship encountered this big iceberg that they hit it and it started to sink, and more than half of the passengers died in the in the incident. So if you can repeat this thing again today. So let's say in 2012, 100 years after that. So if the ship again sail in the Atlantic to from England to New York, so what will happen is that they will not encounter the big iceberg anymore. So what will look like is that this one here, which is a small, and you can see the polar bear is actually trying to sit on that small iceberg, what is left of it. So this is due to what they call as a global warming. But this is not just a cartoon character, but it's based on the real thing. If you look at the next photo, you see there, it is real actually. You can see that it's clinging to that small iceberg. So what happened is because of the environment. So this is our talk for this afternoon for about half an hour to 40 minutes. So what is combustion? It is all mostly due to combustion. So what is combustion? It's a sequence of exothermic chemical reaction between fuel and oxidant, which is actually air for our case, accompanied by product of heat and combustion of chemical species. Fuel of interest often include organic compound like hydrocarbon in the gas, liquid or solid phase. So this is actually the mathematical or the chemical formula equation reaction that takes place where we have the hydrocarbon fuel. In this case, is methane, CH4, and then we add it with oxidant. In our case, it's the oxygen, and it will only, if the combustion is complete, only will produce carbon dioxide and water vapor. So these are the only product of combustion. But usually our combustion is not complete. When it's not complete, it produces a lot of other substances. So these are the product of incomplete combustion. NO, NO2, CO, CO2, and the rest. So some of these gases are actually very, very toxic, like sulfur dioxide, for example. So emission is a term used to describe the gases and particles which are put into the air or emitted by various sources. It can be from car, factories, aircraft, from other moving vehicles and so on, ships for that matter. So what are the type of emission? There are a lot around, but these are the ones that people give focus on, especially the oxides of carbon, like carbon monoxide and carbon dioxide. And then oxide of nitrogen, you have oxide of sulfur, hydrocarbons, and also particulates. Okay, this is from the aircraft point of view, because you are all doing aeronautical engineering, and I'm also from the aeronautical engineering background, and I'm also focusing on the propulsion because my master's degree is actually in aerospace propulsion. That's why most of my actually research are in this area. Okay, you can see that when the aircraft is flying, even at 30,000 feet in the air, is giving out all this kind of emission. Okay, so like CO2, NO2, and so on. It's very bad for the human because it can actually harm to people who have this asthmatic problem and so on. It can cause cardiovascular disease and what's not. And SO2 is actually very, very toxic and very, very corrosive. Okay, you can see that this is what they break down for 1 ton of kerosene, because in the aircraft the type of fuel being used is actually kerosene. It's not the normal kerosene, but this is the aviation grade kerosene, okay, like JA1 and so on. So for each ton of kerosene being burned, what they come out is actually the water vapor is about 1.24 ton, and then CO2 3.15, and then NOx is quite big, 6 to 20 kilogram, and then CO about 0.7 to 2.5, and then we have soot, we have this is basically unburned hydrocarbon, they call it, this in the form of hydrocarbon coming out, and SO2 is around 1 kilogram, and the biggest actually is this one, is CO2, and that is actually the product of combustion. These two, CO2 and H2O are the product of combustion. Okay, these are the global emission being divided into sector. You can see the one from the electrical generation is coming from the power plant that generate electricity for our house and so on. This area here about 35%. This area is from the road vehicle, automobile, trucks, everything, van and so on. This is from the manufacturing industry, other industries, and these are other contribution. And you can see that small here is from the aviation. Okay, it's about 1.9%. This is actually the contribution from the aviation part. Okay, and then you can see that the emission also that is being generated throughout is being divided into two big chunk. One is called the anthropogenic, and the other one is actually on. And the other one is called Anthropogenic. So, because I cannot ask you question now directly because you are supposed to listen first. So usually I would like to ask you what is the term anthropogenic means. But in this case, I will answer for you. Actually, anthropogenic is actually man-made. It's caused by human, like the industry, the manufacturing, factories, and from the automobile. These are all lumped together and categorized as anthropogenic emission, as opposed to the biogenic, which happen at naturally. Okay. All right. So I'll move to the next slide. This is for the NOx emission, because one of the major emission being emitted besides CO2 is NOx. And this is the breakdown. You can see that the one from biomass combustion about 16%, and the industry 14%, passenger cars 10%, and so on. So these are all, although this is from the sources actually. These are not, these are from the this is from the let me see. Yeah, these are from the sources of the burning. But this one is in 2010. It's quite old. I should have changed the slide. Didn't have a chance to change it to the latest information. But just to show to you the what you call this, the breakdown. Okay, these are all categorized as NOx, or we call it NOx. So the major contribution actually from NO and NO2. So they are all also addressed N2O2, N2O3, and so on. The other one that being is nitrous oxide being generated mostly in the stratosphere. Okay, what are the effects of NOx? Okay, they are photochemical oxidant, four main what they call it as hazardous effect of this pollutant onto the environment. The one that I showed to you, if you remember the story of the polar bear on the iceberg, is it caused by this global warming, the heating of the world temperature. They cause the melting of the ice and so on. So that's why the ice becoming smaller and smaller, shrinking. Okay, so if you look at all this thing singly, we start with photochemical smog. It was first observed in London, in Los Angeles in the mid 1940s. How it happened? When there are air stagnation, that means that the air is not moving, abundant sunlight. Usually it happens in the morning or midday, and high concentration of hydrocarbon. This is the one that caused the problem, which is in big cities when you have so many cars on the road every day going to work and coming back. All these buses, truck, and so on. So you can see this high concentration of hydrocarbon and also oxide of nitrogen. So this will be the three major precursor to the formation of photochemical smog. So from this you can see that it happens mostly in major metropolitan cities, like in Malaysia. I think Dr. Siva have been there. It's in Kuala Lumpur. That means that Kuala Lumpur, you can see it in the daytime. There is a lot of smoke happening. So this is I think in Hong Kong. I'm not sure. I forgot already where I took this photo. So this is in a clean day. You can see this is how it looks like. And on the left side, on the right side actually, it's my right actually. When it's happening the smog, the photochemical smog. Okay. So this is the what do you call it? The way it's happening due to this what we already mentioned in the last two slides. Okay, so these are the contributors: the factories, the trucks, and and the biogenic, and from the oil tank also is giving out all this hydrocarbon and so on. Even though it's inside the tank, but still, can give some. Alright, so the next one is actually acid rain. This is also very, very dangerous. As we know that the rain falling through the perfectly unpolluted atmosphere will arrive at the earth at a pH of value of 5. This is already acidic. This is a normal rain. Okay. This is the value of the achieved due to reaction of raindrops, this carbon dioxide, because they have a lot of carbon dioxide emitted. So all these carbon dioxide are everywhere. So when the rain coming down through the carbon dioxide, mixed with it comes down as 5.5. Whereas at the neutral pH actually is 7. Okay. So anything which is lower than 5.5, because in the acid scale, the lower the value is more acidic, and the higher is more alkaline. So if anything lower than pH of 5.5 is considered as acidic. So acid rain has several damaging effects on ecological system, especially mountain lakes and streams. Lake acidification tends to reduce the population of the inhabitant, especially fish, because you know that the lake is full of these water animals like fish, frog, and so on. So they have to endure this pH of at least, around 4.5 during the very acidic, rain. As seen, this causes dissemination and malformation. So it will kill and deform some of these fish. So many lakes around the world are losing their fish population due to the lake acidification. That means that some countries that actually have this fish as their economical, what do you call it, income. So this would be a very bad things to happen, And sometimes the pH can go down as low as 2.4, and this is very, very acidic. And if you want to compare it, it's just equivalent to the vinegar where you put in your food, to make some taste. So this is the equivalent of it. So this problem have caused losses of millions of dollars for country involved. The main source of acid are from sulfur and nitrogen, which means that SOx and NOx mostly are coming from combustion processes. So what happens when we have acid rain? Actually, it affects aquatic life, just like what we mentioned in the last slide. On the buildings, through time when they have so much acid rain area that is very near to factories or very near to all these big metropolitan city, so the building will actually be being corroded by all this acid rain. It also reduces visibility not only for photochemical smog. Adverse effect on human health itself, they will have a lot of fever and so on, and cause damages to plant and forest. Okay, this is the formation of the acid rain. Also coming from the industry, transport, and also from power plant. Alright, you can see here, this is one of the effects that happened to the building. So this photo is taken in 1908. You can see the figurine there. This is sculptured in it's a sculpture. But in 1969, due to this prolonged acid rain that's happening from time to time, see that you cannot even see the face and the hand and the fingers already. This is the effect of acid rain, and this is what happened to the forest. You can see it actually kill most of the plant, and this is what happened to the fish. Very, very sad. And then the next one is actually global warming, or sometimes referred to as the greenhouse effect. Is a phenomenon described by the rise of the atmospheric temperature. The rise in the temperature is caused by the imbalance of energy of the earth. The sun is the only significant source of energy. The solar energy is delivered by means of ultraviolet, visible by the infrared radiation. Upon incident to the earth, a portion of it has been reflected back, and about 30% is exertion and does not cause the earth heating. If too much of the sunlight is being trapped, so it will cause a heating. So most of it will be reflected back, and some of it will be retained to warm up the earth. Okay, so this is called the greenhouse effect. So what are the greenhouse gases? CO2 is actually the greenhouse gas, methane, ozone, O3, and then nitrous oxide, which is in the form of NO2. This is part of NOx, as we showed just now. And then the last one is actually chlorofluorocarbon. So for you who are still young, you might not know this, but most of the refrigerator before, your freezer at home actually use CFC. But now they know that this is part of the greenhouse gas contributors, so most of these new refrigerator would not allow you to use CFC anymore. So what happened is that gases present in the atmosphere, especially the greenhouse gases that we showed just now, absorb and then re-emit most of the thermal radiation from the Earth's surface. However, the atmosphere emits less energy into space of the Earth, and because of the atmosphere average temperature is lower, roughly about 18. So actually the temperature in the Earth without the trapping of these greenhouse gases is actually around minus 18 degrees C, which is actually very low. So by trapping of this, it increase the temperature up to around, this is the greenhouse effect. Actually, greenhouse is the same concept that we use for agriculture, where you can plant anything or any plantation throughout the year using this concept of greenhouse. Okay, so it can change the temperature of this Earth from minus 18 to about 15 degrees. We are actually, uh, experiencing every day. Sometimes they are hot and sometimes they are cool, depend on the situation. So if this what you call it, everything is actually in equilibrium. I mean, all these gases that have been shown to you are just enough. The concentration are in balance. That means that in equilibrium, so everything will be in equilibrium state. But somehow, the increase in this emission, like for example CO2, being produced a lot more than they should have been produced, ozone, nitrous oxide, and methane, and so on. So there will be an increase in these greenhouse gases, and they trap more of this heat into the earth. That's why we are feeling a more warm atmosphere. That's why all this iceberg melting, and that's why during the summertime, if you look in America where they have what they call is a heat wave and so on, people are dying due to this heat wave, is because of this phenomena. We call it the global warming, and it's actually increasing the temperature of the Earth by about 2 Kelvin per year. Alright, so this is a work by Campbell in 1986. So this is again the greenhouse effect, how it's happened, and this is what it caused throughout the world. So if you heard about the forest fire in Australia a few months back, how it happened and why it's becoming very rapid, and people cannot put out the fire on time because of this heat of the earth, actually the global warming. You can see that this land being dried so much, due to this global warming. They call it also climate change. This again, you can see the polar bear again on the iceberg, the tip of this small iceberg. This is true. This is a real life situation, and this is no joke. Okay, the last is the ozone depletion. The last of the four. The atmospheric ozone layer is a layer of relatively high concentration of O3. Ozone is actually O3, located in the stratosphere at a height about 10 to 30 miles. This layer is very important to society and environment for numerous reasons. So it's a filter for us. Actually, it filters out the ultraviolet. It absorbs the ultraviolet radiation, the direct UV that comes from the sun. if unblocked, can kill plant and animal cells. So this layer will block this direct sunlight coming to the earth. So if direct sunlight coming, it also can cause skin cancer for the human. Second thing is really the ozone absorb ultraviolet radiation. It heats up also the emission. This is again come back to the last phenomena, which is the global warming. Alright. And the third actually is a in the troposphere is actually also a greenhouse gas, like what we already said to you before. Okay, this is the formation of the global warming. How it's happened. Okay, and this is what happened if the sunlight penetrate directly without this absorption. Okay, it can cause skin cancer. You can see mostly, on the on the skin, and also the sources again for this ozone. Vehicle, here you can see the vehicle. I'm not sure whether you can see my pointer here. And then this is from the factory again, and this is from forest fire and so on. This is to show to you who are the major contributor of this CO2 emission. If you look at this particular slide being produced by Alstom, looks like aircraft is giving a lot of this CO2 compared to the other vehicles. Okay, the next one is really the automobiles. I think because the automobiles, the numbers of automobiles on the road worldwide is very, very big. That's why it is a second highest contributor. Then we have the buses, and last is the locomotive. Okay, so these are all the emission by different type of vehicle. Again, this is what happened when we have the combustion, the ideal combustion. I think the first few slides I showed to you. This is what coming out: CO2, H2O. Nitrogen is there. Why nitrogen is there? Okay, nitrogen actually is from the air. When we said that fuel must mix with oxygen to produce the product of combustion during the combustion process, because air is the what being used unless you use pure oxygen. This is very expensive and very hard to get. So what happens for every combustion, like in cars, in factories, and in machineries and power plant, gas turbine, and so on, they use air because air is readily available from the ambient. So what happens? You can bring in the air from the ambient and suck it in for aircraft through the compressor, and we burn it into the combustion chamber. So that's why it comes out of the combustion process. But it's very inert in nature, so it doesn't take part during the combustion process. No chemical reaction, so it comes out as nitrogen, and then some of the oxygen that they are not used will come out, and then if the fuel has sulfur in it, I mean a trace of sulfur or some amount of sulfur in it, like diesel fuel, it will actually give you SOx. But in real combustion, they have more than that. Okay, so beside all this that we have here, we have all this urbane hydrocarbon, CO coming out, and then we have soot, and then we have also NO2 and so on, NOx. Okay, so this is what is actually really happening in our real life today. Okay, this is to show to you this is different type of aircraft, which is actually some of it can produce lower emission. This is the turbojet. It's the first type of engine being used, and then they move to turbofan, and then they increase the bypass ratio. This is about aircraft engine. Maybe we can have another lecture on the aircraft engine itself, what do you mean by low bypass and so on. And they move to higher bypass to reduce the emission being produced. And then now they go to ultra high bypass. I think about some of it go to in the teens, the bypass ratio about more than 10. Okay. Okay, these are actually in the what do you call it? If you look at it at a glance, these are actually what happened from the all the major emission, NOx, uh, carbon monoxide, SOx, and also carbon dioxide. Okay, on human, on plants, materials, and also the climate. So nitrogen, you can see here, it fill all the blanks here. See, all the boxes are being filled by NOx. It gives eye irritation, coughing on the plant. It actually cause growth disturbance and it material like I showed you just now. The acid rain, it corrodes all the rubber, textile, paint, plastic, and even stone. See, and then it's a global warming and also acid rain contributor. Carbon monoxide is stuff the brain of O2. This will cause you death if the concentration is high enough and the time is long enough. Okay, and then sulfur dioxide, as the SO2, is cause respiratory problem, especially people who have asthma and so on. Acid rain, depletion of fish stock and so on, and corrosion to the metal, textile, and stores, and also the precursor to acid rain. And then carbon dioxide actually contribute mostly on the global warming. Okay, these are actually the control techniques. We're talking about combustion process. It's coming from engine, is a diesel engine for automobile or for the factory and so on. And these are the things that we can be doing. A pre-combustion fuel treatment, fuel formulation, fuel switching, dual fueling, combustion modification. You can use low NOx burner. This is also a very interesting topic about how they come up with so many types of different low NOx burner to reduce NOx. NOx is very is a talking point. That's why it come up with all this Kyoto Protocol and so on that we have all the countries in the world have to abide to reduce the carbon and also the NOx to make sure that the environment are safe. We have stage combustion, fuel gas recirculation, pre-burning, water and steam injection. And so this is during the combustion process. The other one is before the combustion, and the last one is after the combustion. That means that you can try to modify these techniques to suit your, your need. Whether you do it before the combustion, during the combustion, or after the combustion, which is SCR, SNCR, hybrid, SCR, and also reburning. So in UTM, we use some of these techniques for our research. Fuel formulation we have the low NOx burner, we also done the stage combustion and also the SNCR. So I'll show you some of the research that we have carried out in UTM. These are the control technique, the stage combustion. We have either the radial staging or we have it on the, this is the fuel staging, this is the air staging, okay? Okay, this is what we have used in our lab. We do the both stage and also the fuel staging. So these are some of the results that this is survival. This is to show to you the type of fuel staging. This is radial and this is actually axial. The bottom one is actually the axial. You can see it's happening here on one combustor and the other combustor. They are in tandem. This is really side by side. So this is actually radial staging. This is what we use. We conducted. We use this one as a modification. They call it low NOx burner, where we use what they call as a swirling flow, different swirling angle. So by this, we can see that by using a different angle, we can actually. This is the temperature. This is the emission. This is the temperature again. This is the this is different angle. Okay, I know it. Because you can see there, with a 30 degrees angle, the temperature is about 1000. Okay, and then you can increase it to 150, 1050, and then this one is about 1000 back, and then it reduces again. So that means that somewhere the angle between 40 to 50 will give you the maximum temperature. When we say maximum temperature, that means that the burning is very good. They give you a lot of output. So, but on the downside, the temperature of the high temperature is that NOx will increase, but you get maximum of the output from this combustion. Okay, so when you look at the NOx, so the temperature, the angle of 60 degrees will give you very high, and then it goes down to actually, oh no, this is actually at 30 degrees because of the temperature very high, because very high temperature just now. If you look at this one at 30 degrees, okay, and then at 40, and then we look at this one, the temperature will cause NOx to be high. So that's why at 60 degrees, because the temperature is lower, so the emission actually reduces. Alright, so this is for the CO emission, because this is actually the invert of NOx emission. Okay, and this is for the sulfur. Sulfur, when we use fuel that contains sulfur, then the sulfur emission will be high. Then we also use air staging. This is what happens, the temperature when we have different what do you call this, air staging amount of air being used. Okay, and look at these are all the temperature. Okay, this is the emission. So the first one is without the air staging. You can see here the red one. If you use the air staging, the emission is very high, especially this is NOx emission. Okay, and then when you use air staging, this is actually at different point from the burner inlet. So we put the air at 200, and then at 300, and also at 100, 200, and also 300 millimeter from the combustor entrance. So the first one, actually the black one here at 300, we can reduce even further the emission of NOx. Okay, that means this is, we put in extra air. They call it secondary air into the combustor. That means that we put the main air in front of the burner, and then we add some more air later, so that this air will actually complete. So this is for the CO. Again, you can see the black one actually at 300 gives you the lowest, and this is for the CO2. Okay, all right, and the last one that we have, you can see that the first two actually is for the during the combustion. Okay, so this is the post combustion, I mean after the combustion. So they use SNCR. So in our case, we use ammonia injection. Okay, so this is different. What do you call this? Different injection temperature and so on. Okay, so we can actually see again. We can actually reduce the emission of NOx. All right. Okay, so these are the SNCR. Now again, you can see this one. Even the temperature also plays an important role. See on this side, this at different temperature, the blue and the red one. Okay, so it means actually if you use a higher temperature, so this emission can be actually reduced further. And then we go into the fuel formulation, which is called the biodiesel. This is one I think I went there to Chennai to present. This is part of the presentation. We use from different sources. In Malaysia, basically we use palm oil. Those are the major product of the Malaysia plantation. So we use palm oil as our biodiesel. This is what we use. We have a different blend. We blend it with diesel because we don't use it 100%. We use it at maybe 5, 10, 50% and up to 30%. And this is our rig. When we test it in the burner, you can see here it's burning there with very nice blue flame there. It's very hard to get actually blue flame during combustion. I can see there again the blue flame being generated. This is using biodiesel. And this is the flame length at different equivalent ratio. Okay, so these are the result of the different blend. So we have a B0 is actually diesel and B100 is 100% and 95% diesel. So we got B10, B15 up B25. So we run the test. So this is what we get. So the highest one, like B25 here, you can see here, it's at the bottom here. Alright. Again, it gives you a lower temperature compared to the diesel. This is up here. Okay. Again, if you remember, I told you because the NOx actually is being affected by the temperature. So when the temperature is high, you can imagine that the NOx will be very high. Okay. So this is for the different equivalent ratio. Okay, so this is the emission. You can see there, the emission of pump at the B25 is this one here, the lowest one, as compared to diesel up here. So for the CO, you can see here at the bottom here, this is B25. Before that, so actually now in Malaysia, this is for burner actually, but in Malaysia nowadays they are actually trying to use pump biodiesel. They are pushing for B30 in the near future. Now they are using B20 in all the cars. They are using diesel fuel. So our petrol pump in Malaysia, they use B20 biodiesel. Okay. And the next project that we have is actually on the micro gas turbine. So actually we actually fabricated ourselves this micro gas turbine using a turbocharger from a truck. Actually not truck, it's from a big car actually. So we can actually run them. This is actually a gas turbine compared to the other one, it's only burner. So now we are using biodiesel that we already produced before for the burner, and we are running them under the micro gas turbine to see the performance. And also the next step that we are doing is actually to produce biojet, which is called also biokerosene from palm and coconut, and also try to use this one later in the micro gas turbine. So this is our current project that we are doing in our lab. So these are the MGT designed to utilize biodiesel from different sources, and then we are moving to biojet, not only biodiesel. Okay, so these are the one that we have at the moment from our test. We have three different fuel. We have POME is from palm oil methyl ester, and then J is from jatropha, actually jatropha oil methyl ester, and then WCO is from rice cooking oil. So you can see that the emissions are like this. Okay, this is from the graph. You can see. So that means that WCO emits lower emission. Okay, NOx, CO, SOX, and also unburned hydrocarbon. So even for your information, all these fuel except for diesel, we produce ourselves inside our lab. That means that we take in the palm oil and we produce them into biodiesel, which is methyl ester, palm oil methyl ester. Even jatropha, we have the crude jatropha oil, and then we produce the biodiesel. I mean, we process it into biodiesel through the trans-esterification process, and also the rice cooking oil. That the oil being used like in maybe Kentucky Fried Chicken, they cook a lot of, they fry a lot of this chicken, so that oil we can use and transform it into biodiesel. So this is what is happening. Okay, and this is the ongoing research in our lab at the moment. I think I present this one also uh, last 2 years in Chennai regarding this different fuel. Okay, if you're interested to know more about this subject, you can purchase my book. Okay, this is just some advertisement because I've written one book on this green combustion used for low emission burner technology. So the link is here. I can pass this one to your professor later. If you want to purchase it, you can purchase it online. So that's about it. So now I will open you guys for some question and answer. So I pass back to you, Prof. Yeah. I hope you all enjoyed the presentation.
Yeah, very
I
nice,
was,
Professor.
I was, I was like talking to myself because I cannot see you guys. Okay. Any
Professor,
question?
yeah, Professor, you please open the Q&A tab.
I see. Is it the hand one? I think Kartikeyan, you asking a question?
Yeah. The one
Yeah.
person,
Can you ask now?
yeah, he's asking what is mean by B5, B10, and B20.
Oh, okay. I just explained this now. Maybe because it's not clear. The B actually stands for the percentage of biodiesel inside the fuel. Like you have a B10, that means that 10% is actually from the biodiesel. Is it palm oil or jatropha like this one, POME, JOME, and the other is diesel. That means that 90% diesel. So 15 also, B15 actually 15% biodiesel, and the rest are diesel. Okay, I saw the hand just now, Tamikani. You still want to ask question?
That question of Dr. Shanmugam.
Is it?
Yeah.
Oh, okay. All right.
Next,
Any other question?
next question asked by Karthikeyan KV.
Kartikeyan, yeah.
Yeah, why can't we use plasma combustion?
Do what?
Why can't we use plasma combustion?
Blah?
Plasma combustion. No, sir,
Mag
just you open Q&A. There is one tab,
uh-huh.
below attendee. One
Uh-huh.
tab is Q&A. You just click it.
Okay.
Then you can see the questions.
Oh, okay. Where is it?
That top left corner.
Top left corner. Okay.
There is attendee, below that Q&A. Yeah, you can see that.
Okay. Plasma. Okay. Actually, we reserve the question because we do not use this kind of research at our lab. So I might not be in the stand to answer that question because I haven't tried the plasma combustion. But you have to remember one thing. When you are talking about all this kind of combustion, people will actually revert back to the conventional. The conventional, that means that people are using on a global basis. You go back to diesel engine actually. It's a lot on the road. That's why we can see why people are still not using EV, electrical vehicle, versus diesel because it's a lot cheaper. It's ready. People can just go to the petrol station and just pump it and get your fuel. So on a daily basis, people will still use the conventional engine. So plasma conversion, I'm not very familiar with it, but if something that is bombastic in name, maybe people cannot, not everybody can afford to use it. Okay, the next one. Oh, the rest are only thank you. All right, thank you very much. I actually enjoy talking to you guys, and I should be thanking you for actually inviting me to give this talk. The other one is what about NOx emission in biodiesel? Okay, NOx emission in biodiesel, there are actually two. This is from Dr. Gofinas. Is it you? Okay.
Yeah.
There are two school of thought. Some of it say that because the temperature actually increases a bit, that means that the NOx emission will increase in biodiesel compared to the diesel. But somehow, some people also made some research. They said that this biodiesel actually have some extra component of oxygen inside it. I mean that they have more oxygen compared to maybe other fuel. So the extra oxygen which is inside the fuel helps during the combustion to make it more complete. That's why it reduces the emission. So but this thing is still actually being a topic of discussion. So the answer is just like that at the moment. So that means that NOx can in some way reduce the emission. I mean the biodiesel can reduce the NOx. All right. Okay, I'm running low on battery. Maybe I'll grab my, give me 1 minute to grab my
No problems.
charger. Just a
Please.
tak ada je. Okay, sorry. The battery was
No.
running low. Okay, there is a next question. Instead of zinc palm, can you suggest some other biodiesel? There's a lot because I think the one that I showed to you just now from the slide, in that test only we have 3 different type of biodiesel. We have palm oil, we have jatropha. I think jatropha is one of the things that we can use because they are not used for cooking. So that is again it's not edible. It's a non-edible oil. So it's a good choice. And I showed you just now. I think there's another one which is waste cooking oil. But the problem that we need a lot of oil if you want to use it, for daily consumption, like for cars and so on. So they need a lot of this oil to be around. So it might be a problem because we need them for the for the biodiesel. So you can use jatropha and I think other places they use different one like rapeseed and so on. And in my lab we even try brand oil and also we try sunflower and so on. But mostly these are edible. When you talk about edible oil, then people mostly will go against it. Okay, because it's food for oil, food for fuel we call it. So better try to use something that is not edible, like jatropha just now, because we cannot eat we can use the oil for food, and we can use waste cooking oil. Okay. Okay, what biodiesel affect the working hours ability of the engine? Yes, this is still a big question mark. This one there we need to run it on the long-term basis. Yes, it do have some effect, but it depends on the quality of the biodiesel being produced, because we can transform the biodiesel and make it very close to the properties of a diesel. Okay, by doing this, that means that it will perform as a diesel and will not trouble the engine and so on. But this is still a big debate also. But now in Malaysia, I think we're using V20, and so far there has not been any any issues at the moment. Okay, so I think that most of the thing has been resolved. Okay, any other question there? What about combustion temperature? I showed you the graph just now. In some oil, just come down. So when it come down, that means temperature coming down. The combustion temperature, that means that we do not get the maximum output from the fuel. That means they have to burn more fuel to get the same effect. So this is one. But with some biodiesel, we can get quite high temperature depending on the type of sources. They call it feedstock. Feedstock can come from palm, can come from coconut, can come from jatropha, and so on. So this one it varies, depends on the feedstock. And the last question here is biodiesel applicable in combat aircraft? Not as biodiesel. When we use aircraft, we talk about bio-kerosene. Remember just now I mentioned during the last part of the slide, we are trying to embark on this new research, new field, which is biojet, we call it. Some people call it bio-kerosene, some people call it biojet. It has been used. If you look at in the news, or you can go back to the internet, find the things that are happening during the 2009, 2008, or 2010. Most of the airlines all over the world have tried using biojet, some kind of biojet, different sources and so on, but they use it about 5 to 10% only on trial basis, and it has been proven to perform well. So it does on the commercial aircraft, so I don't think there's any problem to use it in combat aircraft. But the research is still ongoing. All right, any other question? I didn't see any more on the screen, so I think one last question for you.
No, you answered for all the questions, Professor.
Okay, no problem. I tried to answer as much as possible. So I hope you enjoyed my presentation.
Yeah.
Might not be there, but just to keep you at home and feeling away from this
Yeah, really,
virus.
your lecture was very wonderful, and I hope participants are enjoyed with your lecture.
Okay, thank you very much. I
Yeah,
love
on
it.
behalf of, yeah.